we will insert the module for ramping. So as you can see here, now we are inserting a new test module called the ramping test module, and here another ribbon available, which is the ramps. So we can add ramp before or adding ramp after, the same as the state sequencer. We can add state before and state after, and here we can add a ramp assessment, and also we can add a calculated assessment. So what's the difference between ramp assessment and calculated assessment? As you can see from here, which is a ramp assessment, here we have the pyramid shape, and we can configure the pickup and the drop-off values here to be assessed in this module. And then we can get these two values, which is the pickup value and the drop-off value, to get the reset ratio. Okay, because in some test reports you need to create or calculate the reset ratio, which is the drop-off value divided by the pickup value, and it should be greater than 95% from as a per unit division. Okay, so if you have two values, which one value is x, which is the pickup, other value is y, which is the drop-off, so you can calculate assessment based on the result you get it from the ramp assessment. Okay, so this is the main difference here in the ribbon. Now we will start to explain the test view. As you can see here, we have, this is the test view, here is the detailed view, here is the signal view, and the calculated assessment, as you can see, and you can toggle it between the signal view and phasor view, impedance view in case of you are injecting or ramping up and ramping down impedance value, and here is the report view. Okay, starting with the test view, as you can see, set the set mode to inject a direct phases or line to line or symmetrical component if you need to inject positive sequence current or negative sequence current or zero sequence current, and power, fault values, impedance with constant current, impedance with constant voltage, impedance with constant source impedance, and impedance also in percentage with current and voltage and source impedance constant. Okay, so you can ramp all of this. Just we will start with the direct one, which is the set mode. Here you can identify the signal to be ramp up or ramp down. So for example, I have to I want to inject overcurrent, so I will choose the line to line or 3 line to not interfere with the ear support if they are configured in the same start contact or trip contact. So I can select the 3 phase, as you can see here. Then I can select what the quantity I need to ramp. The quantity is the magnitude or the phase angle or the frequency. Okay, so I will choose the magnitude because I need to check the pickup and the drop off. Then I have to define here from and to. From is the start value, which we agreed it will be 80% from the setting value. So for example, 80% from 1.8, which available in our presentation will be 1.4, I think. 1.4 ampere up to I think 2.2. Okay, so the start value will be 80%, the end value 120%. Here is the delta, which we calculate using the formula, the tolerance divided by 4. So the tolerance of 1.8 amp, it was 54 milliamp. If you divide this 54 milliamp over 4, it will give you 13 point something. So we can make it 13 milliamp. So this is the step size. And the delta time, because of the start signal is immediately and instantaneously getting start signal, so we can keep it 100 millisecond or 50 millisecond based on your application. Then for the ramp 2, if you see now starting from 1.4 here in the signal view up to 2.2. In the second ramp, which is used for the drop-off, I will start with the end value of the ramp 1 to get the pyramid shape. So I will start from 2.2 up to 1.4. And the delta will be minus 13 because it's decrement, it's not increment. And the DT, I will keep it as it is, 100 milliseconds. Now I finish the configuration of the ramping in the test view. And if you see here, you will find the steps from 1.4 up to 2.2 with increment of 13 milliamps. So you will have 63 steps. And this 63 step will last up to 6.3 seconds. But in normal cases, it will not last at that time because it will be triggered by the pickup current. So it will not go for 1.2. Okay. Once it gets the pickup value, it will start decreasing to get the drop-off value. So it will not take all this time. Just I give you some overview about this calculation. And here is the stop condition. As you can see, here is the binary input. Suppose we use the binary input 2 as a start contact for the overcurrent. So here is the trip condition. It will be from 0 to 1. And this condition it will be from 1 to 0. Okay, because this is the pickup and the drop off. Once you finish this one, you can go for the detailed view. if you selecting the ramp 1, you will find the IL1, IL2, IL3 is in gray color, which means it's ramping. Okay, so this values is not manually controlled. Now it will be automatically ramping up and ramping down based on the setting you adjusted. Okay, then you will have the ramp up and then the ramp down. In case if you don't need the other phases and also not needing the voltage phases, you can remove it from the local hardware configuration. So I will go for the analog output. No use for the voltage signals, just to make it easy for you. And also the current output P is not used in that case. Then also I can use this one. Binary input 2, as you can see here, is start. And binary input 1 is the trip contact. Then I will click OK. And as you can see here, now I have the 3 analog output only for current. Okay. Then, yes, if you click this one, if you press the help button and go for the force absolute, interesting view, you see this force absolute phases. Now anything you need, you can get it from the help button, just you press the help. And if you can see here, this with this feature, ramping at the current phase angles as the moment of the execution of ramp 1 is stopped to the user defined start value of the succeeding ramp 2. So once the ramping 1 is finished, it will start the ramping 2 at the same value. If you need more details, as you can see, you can press more details and it will give you the some explanation and some examples of transition between the first step and for the second step. But in default, there is no need to get this value, because once it gets the start contact changing from 0 to 1, it will be immediately start decreasing from 1.2 up to 0.8 until getting the start contact from 1 to 0. Then we have the binary output in case if you need to simulate any kind of rotation event to the relay binary input, you can use the binary output in the same way. And also we have here the trigger, which is the most important setting right now. As you can see, this is the stop condition of ramp 2, and if you click on the ramp 1, it will give you the possibility to check here. And as you can see here, we define the binary trigger. So this ramp will be stopped if the binary input 2 starting changing the status from 0 to 1. Okay. So here is the binary input 2, if you can see, and here is the status is 1. And if you go to the ramp 2, here is the status is 0, as you can see. So here is the stop condition, which you can see also from here and from the assessment as well. So for this assessment, we add to assessment. If you need to add more, you just click and add. Okay. If you need to make copy for one assessment and duplicate, you can take copy and make paste again. So for now, we need only 2 assessments, one for the backup and the other one is for drop off. And this one you have to identify which ramp you are working with. So for the backup, I will configure the ramp 1, and the condition is binary input 2 from 0 to 1, as you can see. And here is the signal, which I already choose it from here. So it will be directly written in my assessment. And the nominal value, now the nominal value is 1.8 from our example in the presentation. What is the deviation? It is 54. The stop value will be 95 multiplied by 1.8. So if you multiply by this value, 0.95 it will be 1.71. So 1.71. And you can define also the 3% from 1.71. You can multiply and you can write it here. I think it will be 52 milliamp, something like nearby this. Now we adjust the backup and the drop-off assessment manually. And I calculate the assessment, as you can see. I calculate everything, the delta T, the delta I, the start value, the stop value, and the assessment as well. So it's completely general test module. You have to identify and configure all this by yourself. Okay, and here is the main difference again between the dedicated one and between the general test module. For the calculated measurement, I have defined this name to be the drop-off over the backup, and I can rename it to be, I can give it name to be reset ratio, and you can identify what is the calculation you need. You need the division, you need multiplication, you need any kind of calculation here. Now I need x to be divided by y, and it should be more than 95%. Okay, and you can give us also assessment. So let us suppose it will be 0.02, and here 0.02. So it will check the actual values and it will compare with the nominal value and it will give you the assessment. Same as here, it will compare this actual value with the pickup value. Okay, so for example, if we press start, and here is the simulation as you can see. So we are in the offline mode. So now we're getting the actual current is 1.75 amp, and the deviation is 49 milliamp, but it's still accepted because we have a tolerance band of 54 milliamp. And the same for the drop-off, and the calculated measurement also by division is getting 95.95, which means is accepted. And if you can see the signal value here, here is the pyramid shape, and it will not reach to the 2.2. Once it's getting the pickup value, which is 1.75, it will start to ramp down to get the drop-off signal. If you are going back like this, you will see the status of the binary input 2, which changing from 0 to 1, after that changing from 1 to 0, in the ramp down to get the drop-off value. And here is the phasor view of the 3 phase of current. Here is the impedance view. If I change the set mode to be impedance mode, it will give me the impedance plane characteristic here, and it will allow me to put any value to ramp up or ramp down the impedance itself. Okay. Then we have the report view. As you can see from the report view, we have now the test setting, the ramp states, and also we have test module and the assessment result. Suppose I didn't need all of this, I need only the assessment result. I can, as I explained before, you can define and you can remove this test setting and remove this test module. So it will give you only the assessment result. Once you click OK, it will be adapted as you can see here. So now this is the report view. It's only the assessment result. Okay. Now we finished the ramping module. We will check the pulse ramping module. The same way, I will insert the pulse ramping module, which is here. You can rename this one. You can click on the properties and rename this file. So you can, for example, you can make it I double greater, pick up and drop out. So you are free to change this test value. Also, you can add group. One group for the stage 1 and one group for the stage 2, and so on. As you can see here, here is the shape of the pulse ramp. First, let us unconfigure this voltage and current output P to be clear for everyone. So no need for voltage right now, no need for current output P. And the binary signals here. Here is the trip contact, which is the binary input number 1. So looking for the test view of the pulse ramping, here is the fault state and here is the reset state. So the reset state, it should be less than the value of the stage 1. Okay, so you can keep it 1 ampere or you can keep it 0.1 ampere as a pre-fault state. Okay, just to allow the relay to reset. You can keep it 0.1, and here also it will be 0.1. And you can press equal magnitude. And for the fault state, I will choose the direct mode also, and I will choose which value I need to ramp. If I need to ramp the IL1 only, or IL line to line fault, or 3-line fault. So in that case, I will choose the 3-line fault. As you can see now, all 3 line is gray, which means it will be used for ramp up and ramp down. Okay. And I will choose the quantity to be a magnitude, not phase angle and not the frequency. And here is the ramp configuration. So we have a start value, which is from, so for the 6 amp, multiplied by 80%, it will be 4.8. So this is the start value. The end value, it will be 1.2 multiplied by 6, it will be 7.2. Now I have to check the delta, which we took 180 milliamp over 4, it will be 45 milliamp, so I will make it 45 milliamp. So this is the step size, and as you can see here, here is the ramp pulses in the phase view, in the time signal view. Now I have to identify the pre-fault time to be enough to allow the relay to make reset. Okay, so I will make it, for example, 200 millisecond. The reset time also 200 millisecond. Here is the fault time. Now, this fault time should be greater than the second stage trip time and less than the first stage trip time. So it should be greater than 100 and less than 500. So I can put it 300 milliseconds to be enough to detect. So this is the fault time, 300 milliseconds. It's enough to get in the trip contact of the second stage, but it's not long enough to get the trip contact of the first stage. So now there is no interference. I can use the same contact for checking the pickup and the drop-off. And here you can see the number of steps, which is 55 steps, and the maximum duration time will be 27.70 seconds. And because now we are checking the stage 2, it will be assessed with the binary input 1, which is the trip contact, and the nominal value is 6 amp. The tolerance is 180 milliamp. The same here, 180 milliamp. So it will compare the actual result with the nominal value, including the tolerance, plus or minus 180 milliamp, and it will give you the result. Okay? The same way, we have different views here. First one is the time signal view. Second one is the phasor view. Third one is the impedance. The fourth one is the report view. So let us start offline to check how the CMC and test universe will respond. Here is should be the actual pickup value, which is 6.015 amp, and the deviation is 15 milliamp. And if you look to the time signal view, you will see the trip command starting from 0 to 1 and ending from 1 to 0. Now we explained how to do it manually, okay? But what if I need to be linked to my values? Okay, and this is the automatic solution using the general test module. Okay, so this link, instead of I put it 1.4 ampere, it will be, I will connect it 0.8 multiplied by the value. Okay, so this value, it will be, even it will 1.8 or exchange it will be multiplied every time with the 80%, so it will give me the start value each time. So no need to start from scratch every time, because you will finish this relay, you will find another setting in the other relay. So it's not logic to start again from beginning. So you can right click on this start value and choose link to X-ray and choose the value of the overcurrent. For example, I have some stage for the overcurrent, and here is the backup current, which is 1 ampere, for example. So I will put it 0.8 from this value, and it will be multiplied and adapted automatically each time I change this value. And the same way, I will do it here to be linked with the drop-off value, or the same value with 1.2. So each time you change this value, it will be multiplied automatically to get the start and the stop value. The same we can do by the delta I and also by the delta T to be linked with the time. Okay, so you can choose the time and add 50 milliseconds to be long enough to get this trip command or backup current. Okay, the same way you can do it here in the ramp 2. And if you change, as for example, if I change this current, which already adjusted to be 1 ampere, I can adjust it to 2 ampere, for example. So you will see now the start and the stop value is automatically adapted to the new value. So no need to start from scratch. So if you have this kind of application, you can use also the automated solution using the general test module, but just use the link to X-ray feature. Okay. For the dedicated module, don't worry, it will be automatically linked to the REU file and to your parameter setting. But for the general module like quick CMC, state sequencer, ramping, pulse ramping, you can link to X-ray using this feature. So it will be automatically adapted. And for the assessment, by the way, also, for the assessment also you have to link to this value. So you can link the nominal value to be the backup current, for example, and this one also to be linked to the drop-off value. So you can use the backup value multiplied by 0.95, and here is the deviation. You can link also the deviation for the backup ratio. As you can see, we have tolerance absolute, we have also relative tolerance absolute, and also tolerance relative, and it will be automatically linked if you are using the overcurrent module. If you don't use the overcurrent module, you have to be linked using the link to X-ray function. By the same way, you have to link the assessment also to your values. So not only the ramp and the delta I and the delta T, you have also to link the assessment value. Because not every time I will manually enter the expected nominal value and the tolerance band based on the setting value, it will be automatically linked directly to the nominal value. So this nominal value is expected to be the backup signal, which I take it from the overcurrent module. And this overcurrent module is automatically linked to the overcurrent test module. But now we are talking about the ramping. How to use the ramping, just for your information. You have both ways. But all يعني 536 potentially available in our PTL. You can use your time for customize your BTT instead of starting from scratch. This is made for you, free of charge. You can use the benefit of this. Just import the release setting. After that, start to remove and add test modules based on what you need. But it will save all of your time. Instead of calculate everything, it will be automatically calculated.